Picture a row of mailboxes. Which positive house number is the first one with no mail in it? Take 1, 2, 0. House 1 has mail. House 2 has mail. So the first missing positive is 3. Now look at the actual job. We get an unsorted array, and we return the missing number itself, not an index. And the hard part is the rule. 1 pass style speed, and basically no extra storage besides the array. Try another example. 3, 4, -1, 1. The answer is 2 because 1 exists but 2 never shows up. What would you try first? Pause before I say it. A very natural idea is a set, like a guest list where each name appears once. Put every positive number in it. Then ask, is 1 there, is 2 there, is 3 there? We stop at 2 because that check fails. That works, yes. But the set is extra memory, and this problem does not let us keep that guest list. You might also sort, but then we spend time rearranging everything, even numbers like -1 and 4 that do not help. So what are we throwing away? The array itself is already storage. Can we use these slots as our record? Here is the right question. If the answer must be between 1 and length +1, where should each useful number live? For length 4, only 1, 2, 3, and 4 can claim home slots. 1 belongs at index 0, 2 at index 1. And here is the move. We place each positive number into its home slot, if that home exists in the array. Same idea, said another way. We are turning the array into its own checklist, where slot 0 answers whether 1 exists. You might think 1 swap per position is enough. Watch out. A new number can land here and still need to move again. You might also be tempted to move duplicates forever. If the target slot already has the same value, stop swapping. So the rule is, while a value is between 1 and length inclusive, and not already in its home, swap it home. Let's walk it slowly on 3, 4, -1, 1. Start at index 0, the value is 3. 3 belongs at index 2, that home is different, and it does not already hold 3, so we swap. We stay on index 0. Now the value is -1, that has no home, so we stop swapping here. Move to index 1, the value is 4. 4 belongs at index 3, so we swap those. Stay on index 1 again. Now we have 1. 1 belongs at index 0, so swap again. Still index 1. Now the value is -1, out of range, so this position is done. Index 2 has 3 already at home. Index 3 has 4 already at home. No swaps needed. Now we do one clean scan from left to right. At index 0 we expect 1, and we do have 1. At index 1 we expect 2, but we see -1. That mismatch means 2 is the first missing positive. Try a different case, 7, 8, 9, 11, 12. None of these numbers even have homes here. Index 0 has 7 out of range. Index 1 has 8 out of range. The same happens all the way across. So after the placement pass, the array is unchanged. Then the check starts at index 0, where we expect 1. We see 7 instead. First slot is already wrong, so the answer is 1 right away. Notice what changed. We did not build a set or sort everything. We reused the array slots as the record. Each swap puts at least 1 number into its home, and the final scan is 1 straight pass. So the time grows with the array length, and the extra memory stays constant because we only shuffle inside nums. Quick recap. Only values between 1 and length inclusive matter, because the answer cannot skip past length +1. We place each useful value into its home slot, value -1, and keep swapping until the current slot settles. Then we scan for the first mismatch. If index 1 does not hold 2, then 2 is missing. And if every slot matches, then all 1 through length are present, so the answer is length +1. Let's write it. First, we store the length. We need it for the valid range, and for the final answer if everything lines up. This first loop is the placement pass. The while condition is the whole safety check, valid value, and not already home. Then we compute the target index and swap. Staying in the while loop handles chains like 4 bringing in 1. The second loop looks for the first mismatch, and if none appears, we return length +1. Back to the mailboxes, we kept putting each letter into its numbered slot until the first empty one showed itself.